This is 5.2, page 227, and it's exercise 18. And there are, it's Hess law that we should use to solve this problem. There is one reaction that is wanted, and it's 2 nitrogen oxides. 2 nitrogen oxide plus oxygen gives 2 nitrogen dioxide. So this call this reaction number 1, and it's the enthalpy change is not known. We want to find that out. And then we know 2 reactions here. We know that nitrogen reacts with oxygen, and that you get 2 nitrogen oxide, and the enthalpy change for this reaction is known. So it's 180.5 kilojoule, and I call this reaction number 2. And then we have the third one that is known as well, and that is nitrogen plus 2 oxygen, giving 2 nitrogen dioxide. That's number 3. And the enthalpy change for this reaction is 66.4. Both this reaction are endothermic. Okay, let's look down. Of course, we have to use number 2 and 3 to find out number 1. And if we look at number 1, you can see that we have here to the left nitrogen oxide that is consumed, and we produce nitrogen dioxide. If you look at number 3, we produce nitrogen dioxide, so this one is perfect using as it is, because we produce the right thing. If we look at number 2, you produce nitrogen oxide, but in the wanted one you consume nitrogen oxide. So we can't use number 2 as it is. We must change the direction of this reaction. So I'm going to write a third reaction now, no, number 4. And that is known as well. And it's number 2, but in the opposite direction. So I'm writing 2 nitrogen oxide, giving nitrogen plus oxygen. And the enthalpy change of this reaction have the same value as number 2, but opposite sign. So it's minus 180.5 kilojoule. Okay, now we can call this number 4. Now we're going to add the reactions here. And we're going to add 3 plus 4. And if we are lucky, we get number 1. So let's do, when we add reactions, we take everything that we have to the left in number 3 and number 4. So to the left in number 3 is nitrogen, N2, and 2 oxygen. And in number 4 to the left we have 2 nitrogen oxide. So that is everything to the left. So to the right in number 3 we have 2 nitrogen dioxide and number 4 nitrogen plus oxygen. If we can cancel things here, I hope we get number 1. So is there anything we could cancel? Well, we could perhaps look at this one here, nitrogen. Whoops. We have that on both sides, so that can be cancelled. Here we have oxygen, one oxygen, and here we have two oxygen, so we can actually cancel number 2 there. That was not really good. Let's see if I can get it nicer. Take a small one there. Oh, I take away the 2 there. And what we have left now is one oxygen here, reacting with 2 nitrogen oxide, giving 2 nitrogen dioxide. Exactly the same as in the wanted one. Nitrogen oxide plus oxygen gives 2 nitrogen oxide. And the enthalpy change now for this reaction is, of course, equals delta H3 plus delta H4. And the value, if we want that, delta H of the wanted one is number 1 actually, equals, and 3 was 66.4, and 4 was minus 180.5, and that equals what? Minus 114.1 kilo. So that is the enthalpy change of the wanted reaction. Hope you got it. Okay, now we're going to solve the same problem, but we shall use an enthalpy cycle instead of adding reactions. So the wanted one, I'm going to write the wanted reaction first, and that was 2 nitrogen oxide plus O2 gives 2 nitrogen dioxide. That was the wanted one, delta H1. And then we should write the known reactions, and then we have one reaction that produces nitrogen dioxide, so I write that one in this direction, and that is nitrogen plus 2 oxygen, and this is delta H for this one is, call it 2, is 66.4. 66.4 kilo. Fine. And then we have the reaction where we produce nitrogen oxide, and that is this one. And if we call that one for delta H3, the value is 180.5. kilo. Okay, if you know how to add vectors, you can see actually that delta H 3, I'm sorry, delta H3, that is this one here. If we add that with delta H1 here, we get this one, delta H2. So delta H, oops, wrong, take that away. Delta H3 plus delta H1 equals delta H2. And we want to find out delta H1, so delta H1 equals delta H2 minus delta H3. Okay, let's put in the values. Delta H1 equals 66.4 minus 180.5 equals minus 114.1 kilo. And that is the answer. Do you think that is more easy? Then use this model.